Alright, so this video is about what's called synthetic division, and we're going to go through a couple of problems where we do division just like we did with polynomial long division. This is just another method that we can use that is a little bit cleaner. It's not going to take up as much space on your paper, and it's probably a little bit quicker than polynomial long division was. So this is something that we use a lot just if we need to quickly get some information out of the problem. And you're going to see when we do something called the remainder theorem that we use synthetic division a lot of times to quickly get the answer. So there are a couple things that have to be true. This is why we need the other method, and we can't just use this. Synthetic division can only be used in specific cases. So if you take a look, I'm telling to use this method, two things must be true. The first thing is that the denominator, and both of these things are about the denominator, which we call the divisor, must be of degree 1. And what that means is that I can't have something like x cubed or x to the third or x to the fourth. It has to be x to the first power, which means when you look at the variable, you will not see an exponent, right? Because the exponent's 1, we don't really usually write x to the first, so we're saying just regular old x, okay? The other thing that has to be true for us, and what we're going to learn, is that the coefficient of x in the denominator, again, we're specifically talking about the denominator, has to be 1, okay? Synthetic division does apply to larger x values, larger coefficients of the x value, but we're not going to look at any of those. It's a little bit more complicated than what we're trying to do. So let me just give you a couple of examples of things that you might see for polynomial long division and things that you could not do. So for example, let's say the bottom of your fraction, let me draw a straight line, okay? The bottom of your fraction, if it was something like x plus 2, okay, that would be good, right? Whatever's up top, anything can be up top, but if the bottom was x plus 2, that's good. We can use synthetic division for something that has an x plus 2. Okay, here would be another good example. If I said something like x minus 7, that would be fine. I'm allowed to have minus signs. I'm just not allowed to have an exponent on the variable. I'm not allowed to have a coefficient on the variable. Okay, here's a couple that would be bad. Right? If I had something like, okay, say 2x plus 1, that would be bad because that doesn't fit our second criteria that x cannot have any numbers attached to it. Right now there's a 2 attached to it. Okay. Again, this is something that you can actually use synthetic division for, but it's a little bit more complicated, and we're going to stick to simpler ones. So for our purposes, we are not going to use synthetic division for something that looks like this. Here's the other one that doesn't work for it. I couldn't have something like x squared minus 7, right? That exponent is bad. Okay, so if you notice how simple these first two are, it's x plus something or x minus something, and that's it. Any other divisors, any other denominators, we're going to have to go back and use long division like we saw in the last couple videos. So just big ideas have to have a very specific divisor, no coefficients, and no exponents. So with that being said, let's take a look at a problem and how it's set up. Okay, and you'll see that this is a little bit quicker and a little bit cleaner, right? So what we're going to do is we're going to use synthetic division to find the quotient. So first thing to note, if you notice my divisor, my bottom of my fraction, it fits our criteria. It's x plus or minus some number, okay? And so here's what we're going to do. I set up a little synthetic division symbol. So it's kind of like how we have our house for long division, and it's just kind of a way of dividing up all of the parts. We have something similar for synthetic division, okay? And we're just going to draw a straight line down, okay? And then you're going to draw a line across. So watch what happens, how I set up the numbers. I'm going to take each of the numbers that is in front of each of my variables, okay, the coefficient numbers, and I'm just going to write those. Okay, so I'm going to say 3, okay, I have a 4, I have a negative 2, and I have a negative 1. Okay, and if you notice with the way I drew the synthetic division symbol, I left myself space for a row. We're going to actually put another row of numbers right here. So you want it when you draw your synthetic division symbol, you want to make sure that there's space to put another set of numbers below the ones that we wrote. Okay, on the outside of this symbol, right next to the 4 that I wrote, I'm going to go down to the denominator, and in this case, I always have a plus or minus some number after x. In this case, x plus 4. I am always going to write the opposite symbol of what I see. So if this says x plus 4, right next to the numbers on the inside, I'm going to put a negative 4. Okay, so it's always going to be opposite. If I had, for example, a minus 7 here, I would put a positive 7 in that spot. Okay, so that's a little bit tricky. That will take some getting used to remember, and that will come with practice. Okay, so here's how we're going to use this setup to figure out what is the quotient of this division problem. Okay, so what we're going to do is we're going to start off by taking this first number, the 3, okay, and we're going to just move it down. So I'm going to put a 3 right below the number. Okay, and then I'm going to multiply -4 that I have out here times that 3, and I'm going to get a -12, and I'm going to place that here. Okay, so if you notice, I'm going up, okay, to the next number. And then I'm going to just add down the column. I'm going to say 3 and -12. Well, 3 and -12 is -8. Okay, and then I'm going to do it again. I'm going to say -4 times -8. Well, that's +32, and that's going to come up. So I'm going to say 32. Okay, and again I'm going to add down the column. I'm going to say -2 plus 32. Well, that's 30. And I'm going to do another addition. I'm going to say -4 times 30. Well, that's -120. So I'm going to place a -120 there. And I'm going to add down the column again. -1 plus -120 is -121. And I'm done. I can't go any further. Right? So if you notice, what we did was we went multiply, put that answer in the next spot. Multiply, add down the columns to get a new value. Multiply again. Okay, place it in the next position. Add down the columns, and we just continue that until we run out of numbers to multiply. Okay, so here's how we're going to use this information. We have these new numbers: 3, -8, 30, -121. We need to use those to write the answer. So here is the answer to your problem. Okay, we're going to start on the end, and we're going to say this last number. If we cut off that last number, that's not going to be a part of the full expression. That -121 is a part of the remainder. Right, so here's the way it's going to look. I'm going to say that -121 is the remainder, and if you remember, the remainder of a polynomial expression was just always over what we're devising, so over the x plus 4. So we're going to say over x plus 4. Okay, and so I'm going to take that, instead of it making it -121, I'm going to bring that out, that minus sign out, and make that the subtraction symbol. Okay, and then I'm going to work my way backwards. 30. That is the last number of my expression, so that's kind of like the 1. It's the number, it's our constant term that doesn't have any variables attached to it. So I'm going to say, in this case, there's a +30. Okay, and then the next term, as I move along to the left, that's going to be the next variable up. So this is constant, which means the next term is the x to the first term. So that's the -8. So I'm going to say -8 x to the first. Okay, and then I'm going to move again. This is 3 is for the x squared. Okay. And if I had more terms, then that would be x cubed, then x to the fourth. But in this case, I'm going to say this right here, 3x squared minus 8x plus 30, with a remainder of -121 over x plus 4. That is the answer to the problem. So again, I know that this is foreign, this is new, and you might look at that and say, well, that was kind of just strange. Where did this come from? Okay, we're going to look at some more examples, and as we do it, you'll get more comfortable with it, and you'll be able to use it when we do it in class.